Hello everyone. Today we'll discuss about representing real numbers on the number line. Right? Here you see, here you have represented number line like this: 0, 1, 2, 3, minus 1, minus 2, minus 3. You have to find the number line on between 2 and 3. Between 2 and 3, this is 2 and 3. This is 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and this is 2.5. That is, after magnifying we will get this number, that is 2.5, right? Now again, if we find between this number, that is 2. Again we are extending this number 2.3, you are getting this number 2.6 and 2.7. You have to find a number between 2.6 and 2.7. If you expand this one again, that is 2.6 and 2.7, you get 2.61, 2.62, 2.63, 2.64. This is 2.65, 2.66, 2.67, 2.68, and 2.66. This we are getting 2.65, right? 2.65. Again, you have to find the number between 2.66 and 2.67. And here you see, if we magnify this one again, then we are getting here 2.66, 2.67, 2.661, 2.662, 2.663, 2.664, 2.665, 2.666, 2.667, 2.668, and 2.669. Then we are getting 2.665 here. This point is 2665, where after magnifying the numbers. We call this process of visualization of representation of numbers on the number line through a magnifying glass as the process of successive magnification. So we have seen that it is possible by sufficient successive magnification to visualize the position or representation of a real number with a terminating decimal expansion on the number line. Now let us try and visualize the position representation of a real number with a non-terminating recurring decimal expansion on the number line. We can look at appropriate intervals through a magnifying glass and by successive magnifications visualize the position of the number on the number line. Visualize the representation of 5.37 bar on the number line up to 5 decimal places, that is up to 5.37777. Once again, we proceed by successive magnification and successively decrease the length of the portion of the number line in which 5.37 bar is located. First, we see that 5.37 bar is located between 5 and 6. In the next step, we locate 5.37 bar between 5.3 and 5.4. To get a more accurate visualization of the representation, we divide this portion of the number line into 10 equal parts and use a magnifying glass to visualize that 5.37 lies between 5.37 and 5.38. To visualize 5.37 bar more accurately, we can again divide the portion between 5.37 and 5.38 into 10 equal parts and use a magnifying glass to visualize that 5.37 lies between 5.377 and 5.378. Now to visualize 5.37 still more accurately, we divide the portion between 5.377 and 5.378 into 10 equal parts and visualize the representation of 5.37 bar as shown in figure 1.14. Here you see, this is 5.5 and 6. This is 5.3, 5.4. We are expanding 5.3 and 5.4. The 5.31, 5.32, and this again lies between 5.37 and 5.38. Here you see 5.37. This is 5.38. So we are getting 5.371, 5.372, and we are getting this number that it is lies between 5.377 and 5.378. Now it is 5.377, 5.378. Right, and you are getting 5.3771, 5.3772, 5.3773, 5.3775, 5.3777, 5.3779. Right, here you are getting 5.37. This number is 5.37, 5.378. Right, that is why you are getting this number, that 5.3777. This point, right? We can proceed endlessly in this manner, successfully viewing through a magnifying glass and simultaneously imagining the decrease in the length of the portion of the number line in which 5.37 is located. The size of the portion of the line we specify depends on the degree of accuracy we would like for the visualization of the position of the number on the number line. You might have realized by now that some procedure can be used to visualize a real number with a non-terminating, non-recurring decimal expansion on the number line. In the light of the discussion above and visualization, we can again say that every real number is represented by a unique point on the number line. Further, every point on the number line represents one and only real number. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.